Hello YouTube vintage stereo collectors and restorers. I'm sort of just started this one, but halfway through the bias circuit. Let's bring it around this way. Right there is the original. It's one of these. And the original diode pair that's in that bias circuit. Over here it's been replaced. So we've got a 500 ohm pot and two FR1 diodes replaced with a 1K pot and two IN4004s. And that's the neat thing about that series. In this application, which is no more than about 30 volts, you can use an IN4001 or higher, whatever you have on hand. Like a 407 would be fine. And sometimes you gotta wonder, why do I replace certain things? I know to replace the bias pods. This one here, for instance, it was no longer you could turn it, but it was 500 ohms across the pot and nothing on the center one. It just was not doing what it was supposed to do, except it was overheating these transistors by going into thermal runaway. And sometimes they can play like that for a while. These are pretty tough things. This is the UK KA 2000 and that I got a few weeks ago. I wasn't going to restore this one yet, but I've got somebody that's interested in it. In fact, these little amps are one of the most popular units I've done in the last few years. People like them because they're small, but they have the bigger sound of the era. Let's put it that way. If you own one, you know what I mean. It's only 12 watts, but boy, it's a great 12 watts. Anyway, back to this circuit. For whatever reason, those original diodes are very heat sensitive. It's something to do with that, because if you put your finger just there, it will influence the reading as much as the thermistor in the circuit, which is on the other side. Very heat sensitive, and sometimes it takes nothing for it to just drift way off as it warms up. So I replace them. If I do the potentiometer, I do the diode pair. And it's basically cathode to this side of the board, anode to cathode, and anode hooked up to that side. There's actually a little diagram on the board. This is actually a 1K because I intend to change the 2SA56, which is a germanium PNP. It's the PNP driver for this pair here. They tend to go noisy. So you've got a PNP driver that's germanium, but an NPN driver that's silicon. It worked, but now you can actually use a PNP and an NPN that are both silicon. But it takes a 1K pot. You need a little more range of adjustment. Okay, I'm going to go back to this side. I just want to make a point about something else. People ask a lot. I've often got a lot of questions about bias circuits and the Kenwood protection circuit. There's a thermistor right there that's in parallel with the potentiometer that's in the bias circuit, and it sets the bias, basically the drive on that PNP transistor. So this here's thermal compensation. Now the heatsink is the bottom of the case. I mean, it's a very simple thing, right? For whatever reason, they actually work just fine being in that position. But don't get rid of it. The thing will go wild. It will literally, you could turn it on at 10 millivolts. That's across one of these emitter resistors, the 0.47. And within minutes, you'll be up 80, 90 millivolts across each resistor. It drifts that much, and there's not enough compensation as the circuit warms. So this one here is kind of bent over the wrong way, but I'll straighten that out. So that's just the one thing I want to say about that circuit. Now the protection circuit. Let's go back to the other side. So this Kenwood patented protection circuit, it's not fuses or breakers in the output at all. It has to do with the preamp. what it is, here's this transistor here, which is a C458. When it's not turned on, everything's fine. What it does is it takes a sampling of DC voltage before the output capacitor on the center rail, which is an artificial center rail because it's a single-ended power supply. And what it does is, when it gets, it should be idling around 530, 540 millivolts. As you turn it up and it gets to clipping, you get a DC, the DC rises in the circuit. That's what clipping is. It's basically the sine wave being very quickly and harshly bridged, flat, pounded out and bridged. And it's hard on speakers, although I don't think these would damage your speaker. They'd go before anything would be damaged. But so here's what happens. This transistor needs about 600 millivolts to turn on. So there's enough room in that circuit, so as the any kind of DC component signal in that circuit rises, it gets near 600, we'll turn this on. This grounds out the B plus feed to this board, which is about 18 volts. Grounds it out. So then the preamp doesn't work, and then you protected it from going into thermal runaway or blowing an output. That's the theory behind it. There's a way to set it in the service manual using a scope and a signal generator, and you push it to 12 watts with a dummy load. That I've set them up that way years ago, and I found that you could get it to very harshly clip with the factory setup. What you need to kind of do is just look at the voltages. I figured out, I made a note on a schematic here. There it is. On this page right here. It should be 530 to 540 millivolt. And it's basically, we flip it around again. Each channel has its own feedback circuit. Okay? That blue wire comes from one of the transistors here. The yellow one comes from another. And then it goes to that potentiometer through a germanium diode to here. And to here. And then they're bridged together with two more diodes. And then back to that transistor I showed you. You can look up the schematic, very easy to find. So you need about, on this one here, about 540 and 540 here, normal idling with the bias set. And it will do, then it'll do what it's supposed to do. Anyway, that's about all I wanted to say about these. You might wonder why I'm working on another one of these. Well, they are very popular. There's a lot to be said about small, compact audio. You know, there's some Sony pieces that are compact. You know, those vertical tower type of ones. I really like those. I forget them all numbers, but they had a really great tuner, the big round dial. The small components, especially people that are like in their 20s and they're living at a university dorm or something, they like those. So, and they sound great. There are many things about this amp that are very similar to higher end models. Just not as much power and not as many controls. Thanks for watching and listening.